Reasoning Power, Chapter 6, The Law of Logical Analogy. You are now invited to consider that important law of logical reasoning known as the law of logical analogy. This law represents the universal experience of human thought rationally applied and directed. The law of logical analogy is expressed in the fourth of the seven axioms of logical reasoning, which is as follows. The axiom of logical analogy. A few things which are alike in many respects are probably, though not certainly, alike in some other respects. The principle of reasoning is the one most frequently employed by the average person. Many indeed, but seldom use any other form. Rightly understood and employed within proper limits, it constitutes an important rule of rational thought. But the possibilities of the careless and unwarranted extension of its employment by those not recognizing its limitations has caused logicians to advance but cautiously its claims. Reasoning by analogy is the most primitive form of reasoning, and it certainly was the only form employed by primitive man, just as today it is the only form known to the undeveloped races, and indeed the only one used by untrained, uncultured minds, even in civilized communities. It has a valid foundation in observation and experience, and when a single-story structure is erected upon it, it frequently serves well its purpose. But when we attempt to build upon it a skyscraper, the rising structure frequently becomes insecure and often tumbles to the ground. Indeed, usually it is dangerous to build upon it a structure which rises above the ground floor story. Many valuable discoveries have been made through the principle of analogy. Thus, a man who has mined gold in California and who was then visiting in New South Wales noticed that the mountains in the latter country were very similar in appearance to certain mountains in California in which he had dug gold. He, reasoning by analogy, concluded that the mountains being alike in some respects also should be alike in other respects, and so he dug for gold in them. His guess proved to be correct. He found rich ore in the hills, and the result was the great discovery of gold in Australia. Geologists employed the principle of analogy in their judgment that certain rocks were originally formed by processes similar to those observed to be in operation in the present period of the Earth's history. Noticing the marks on a sandy sea beach from which the waves had just receded, they reasoned that the similar marks on certain rock formations were produced in the same way at some early period of the history of the Earth, the soft material afterward becoming hardened by natural processes. Seeing on certain rocks marks similar to those now impressed upon clay by raindrops and by the footprints of birds, mammals, and insects, they reasoned that the markings on the rocks were caused in the same way by prehistoric creatures at some early geographical period when the rocks were in a plastic condition. In the same way, it is reasoned that the printed tables of logarithms used by the Chinese were either copied from similar tables of the English or else both had a common origin. The probability of mere coincidence was overcome by the discovery that certain errors in the English tables were duplicated in the ones used by the Chinese. The analogy was so complete that the hypothesis of copying or a common origin was the only reasonable one. In the same way, it is reasoned that inasmuch as the planet Mars is found to have certain areas believed to be seas and certain others believed to be land, therefore, conditions on that planet must resemble to some extent those on Earth. Moreover, at each pole of Mars, there is observed to be a white rounded spot, which is perceived to decrease in circumference when exposed to the sun's direct rays, and to increase at other times, just as do the masses of ice and snow found around the poles of the Earth. Here, the analogy is so close that astronomers feel justified in believing that Mars has ice and snow at its poles, just as has the Earth. The same kind of reasoning has led to the belief that Mars has an atmosphere with winds, clouds, rain, and snow, very similar to corresponding phenomena manifested on the Earth. The reasoning, indeed, is often carried so far as to reach the conclusion that there is probably life of some kind on the planet Mars. On the other hand, this form of reasoning often proves dangerous. For instance, the close resemblance between two kinds of fungus or two kinds of fruit may be so great as to cause persons to believe that they are practically identical, yet one class is wholesome food, the other class being poisonous. Or the other way around. Certain non-venomous serpents so closely resemble the venomous ones as to be mistaken for them. Children are often made ill or killed by eating poisonous berries, which they have gathered and which they have mistaken for harmless berries of a similar appearance. Many persons have been killed by eating poisonous toadstools under the belief that they are mushrooms, in resemblance being very close. Jevin says, in Norway, mushrooms are seldom seen and are not eaten. Once, when I was there, I found a few and ate them. I was afterward much amused by the people at the inn who went out and collected toadstools and wanted me to eat them also. This was clearly a case of mistaken reasoning by analogy. A physician visiting a patient discovers that there are present certain symptoms which are found in the early stages of scarlet fever, the other symptoms not having as yet presented themselves. He reasons by analogy that the missing symptoms are also proceeding to manifestation, and this in all probability is a case of scarlet fever in its early stages. The scientist examining the fossil remains of an extinct species of animal and finding that it possesses strong, blunt claws, reasons by analogy that the creature had produced its food by scratching or burrowing in the earth. Buckland reconstructed an extinct animal from a few scattered fossil bones. The later discovery of an entire skeleton of the animal proved that his reconstruction had been absolutely correct in both generals and in details. This constituted a most successful example of reasoning by analogy. But once more, there is always a great possibility of error in this form of reasoning. The dog, fearing a stick or a stone, will run away from you when you stoop suddenly to tie your shoe, to pick up a flower, or to turn over a peculiar leaf. It is cruel to reason by analogy that because many drunkards have red noses, therefore all red noses are marks of habits of excessive drinking. The red nose of the quite temperate John Jones must not be taken as an evidence of dissolute habits. We have seen the danger of reasoning that a whale is a fish because it looks like one, swims like one, lives in the water like one. Halleck says many false analogies are manufactured and it is excellent training and practice to expose them. The majority of persons think so little that they swallow these false analogies just as newly fledged robins swallow small stones dropped into their open mouths. The best thought today holds that true logical reasoning should be conducted along the lines of induction and deduction, whenever this is possible in view of all the circumstances of the case, and that analogy should be regarded as merely an imperfect form of these processes, or rather as a form of imperfect induction or imperfect deduction, and accordingly regarded as a makeshift to be employed only when true induction or deduction are impractical under the particular circumstances of the case. At the best, analogy is held to be but a guess, sometimes a scientific guess, or a rational guess, but still a guess at the last. Here is the explanation of the employment by mankind of the principle of analogy. Primitive man soon discovered that superficial resemblances existing between the various things that his everyday experience were reasonably sure evidences of a real inner and essential sameness between these things. One thing was found good to eat, therefore another thing resembling it in appearance must be good to eat. Up to a certain point, this form of reasoning was found to be correct. What was much more to the point with the primitive man, it was better than no reasoning at all. He knew absolutely nothing about certain reasoning based upon careful and extended observation, induction, and deduction. These required more time and attention than he was able to bestow upon them. And in fact, such more complex methods of reasoning never occurred to his mind. The degree of probability found in the results of reasoning by analogy was sufficient to attract his attention and to prove useful to him. So he was content until he afterward discovered a better way, and then a better way, And that better way was really an evolution of the original way, after all. It remained for the careful thinkers in advanced stages of the evolution of the race to discover that the principal value of analogy is to be found in its suggestiveness, and that even where analogy leads to the detection of truth and real facts, it usually does so only when the observations or experiments upon which it is based have been sufficiently extended and carefully reasoned upon. It has been said analogy may be applied with even reasonable confidence only when the degree of ascertained similarity is great and when the extent of the preliminary observation is sufficiently wide. Again, that even where analogy leads to the discovery of truth, the final establishment of such truth is never actually accomplished by analogy, but really by some stricter logical method. Reasoning from analogy results in merely probable conclusions, but the degree of probability may be raised to a high degree by pursuing the right methods and observing the proper precautions. Indeed, in the active affairs of ordinary life, analogy is really the only form of reasoning possible to most of us under ordinary existing circumstances, and we are very often forced to act upon conclusions reached only in this way. Reasoning by analogy, carefully and cautiously exercised, has led to many important discoveries of natural science, mechanics, medicine, psychology, etc. And it is often effectively applied to the practice of law and in judicial decisions. In short, analogy is useful, often necessary, frequently the only possible way, but its application must always be surrounded by the greatest care and exercised with the greatest caution. The essential distinction between analogy and induction is as follows. Analogy proceeds upon the general principle that a few things having many characteristics in common also have other characteristics in common. Induction proceeds upon the general principle that many things have a few characteristics in common. All other things of the same class also have all these same essential characteristics. Further, in analogy, we usually confine ourselves chiefly to the observation of the external and incidental characteristics of the several things in question. In induction, however, we extend the observation and apply it particularly to the internal and essential characteristics of the things examined. We go deeper into the examination and search for the essential elements. The following diagram will illustrate the principal points of distinction between the processes of analogy and induction, respectively. Examples. If we find that X has the characteristics known as A, B, C, D, E, F, respectively, and then find that Y has the characteristics A, B, C, D, respectively, we reason by analogy that Y also possesses the additional common characteristics E and F, respectively, because these are found in X, with which Y has so much else in common. Thus, finding that the planet Venus has the attributes of light, heat, water, and atmosphere in common with the Earth, we reason by analogy that Venus probably possesses the additional attribute of the presence of living things in common with the Earth, the latter having been found to possess it. Induction, on the other hand, would reason as follows. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, members of a general class of things, notwithstanding their great differences in many external and incidental characteristics, are found to possess in common the three internal and essential characteristics as designated 1, 2, and 3, respectively. Therefore, it is probable that the remaining letters of the alphabet class, that is X, Y, and Z, also possess these three essential characteristics, notwithstanding that X, Y, and Z manifest sundry differences in external and incidental characteristics from the remaining 23 letters of the alphabet class. Thus, finding that all known heavenly bodies obey the law of gravitation, the astronomer reasons by induction that a newly discovered star must also obey that law, though he has not as yet had time to examine its movement. Likewise, a chemist finding before him a transparent, colorless crystal compound of carbonate of lime knows by deduction based upon the principles of induction that it will react to other stated chemicals in a certain definite manner. This because all forms of carbonate of lime, notwithstanding their external and incidental differences, have the internal essential characteristic of such reaction. The general rule of analogy is as follows. 1. The greater the number of points of discovered resemblance, the greater the degree of probability of the analogy. The fewer such points, the less the degree of such probability. 2. The inferred additional points of resemblance become the more probable in the degree in which they are related to or essentially connected with those points for resemblance already established by observation and experiment. 3. Discovered points of essential difference often are sufficient entirely to destroy the presumption and inference of analogy based upon many discovered points of external and incidental resemblance. We need scarcely consider in detail the many forms of possible application of the principle of analogy. It is as familiar to you as breathing or walking. You enjoy it in some form during almost every hour of your waking periods. It has its evident uses in forming everyday conclusions, opinions, judgments, and decisions. You should not do without it, even if you so desire. The most that you can do in the matter of its application is to endeavor to employ it correctly, always recognizing its weak points and dangers, and always observing carefully and consistently the above stated rules concerning its degree of value and probability, its use, and its limitations. Probably the best use of analogy is that in which its conclusions are recognized as being merely tentative, i.e., adopted experimentally and for a trial, afterward to be subjected to more careful observation, examination, and testing. By its employment in this way, we often arrive at a valuable idea of a probable cause or a working hypothesis, which afterward may be verified or disproved. Its reports must always be recognized as probable truth, never as certain truth. Jevons ably sums up the matter when he says, in order to be clear about our conclusions, we ought never to be satisfied with mere analogy, but ought to try to discover the general laws governing the case. In analogy, we seem to reason from one fact to another without troubling ourselves either with deduction or induction. But it is only by a kind of guess that we do so. It is not really conclusive reasoning. We ought properly to ascertain what general laws of nature are shown to exist by the facts observed, and then to infer what will happen according to those laws. We find that reasoning by analogy is not to be depended upon unless we make much further inquiry into the causes and laws of the things in question, which really necessitates the employment of inductive and deductive reasoning.